Eric Burgess here, and today we are going to graph this function. So it's a piecewise function, and we're going to need a somewhat sizable graph. I'm going to make it bigger than last time, so we're going to go ahead and make it 2 of these squares down. Just give myself plenty of room. Alright, so let's take a look here at these domains. So we've got everything that's less than -3. So let's come on down here and we'll put down, there's a -3 right there. And then we've got the domain right here for x between -3 and 2. So we're going to come over here to 2. And this is going to be, whatever the function is right here. That's what's going to go in the middle. And then we're going to have everything bigger than 2. So everything that goes on this side. So we have 3 general areas. Area 1, Area 2, and Area 3. Each is going to be populated by a different function, which will be described by these functions right here. So right now it's saying that, hey, if x is strictly less than -3, we should graph it as -2x. So, okay, we look at this and we say, well, we need to know what's happening at -3, right? Because that's where this whole thing starts. So if we plug in -3, we get -2 times -3, that's +6. So I have 6 right here. So I'm going to go ahead and put a hole there. And the reason it's a hole is because we do not have an equals to sign. So this -3 is not included in the interval. And so it gets a hole. And then from this hole and everything lower than it, we're going to be doing this function. So let's go ahead and plug in a number less than it. Let's do -4. Let's find that point. And we can see that this is a line. And in this class, you should be starting to get to the point where you can just look at these functions and sort of tell what their shape is going to be. And so all of these have the form of a line, right? Because the form of a line is y equals mx plus b. Well, here we're just missing the plus b. There's no plus b, but we have mx. See, here's m. That's the slope. So the slope tells us, right, rise over run. Whoops, didn't want to erase that. So the rise over run is -2, and then underneath we can always just put a 1. So we're going to rise -2 and then run 1. So you might be going, how do you rise -2? Well, the way the line would work is we would go down 2, 1, 2, and then over 1. And that would be it. But we can't go this direction because if we start, this would be where our new point is. If we start going that direction, we're going to be going outside the domain. So we have to go the other way. So we're actually going to go up 2 and run 1. So we're going to have a point right here. And we're running -1. So you can flip it. So we could go -2, 1, or we could go -1, 2. And this will make us go the other direction. So this is when our line's going this way. If we want to draw the line going the other way, we can actually go the other way by just simply moving the negative. All right, and so this is the line -2x. All right, so for the next bit, we have between -3 and 2, as is said right here. So it's this middle area. And this is the line that we're graphing, 3x minus 1. So we need to check our endpoints, find out what's happening there. So if we plug in -3, we're going to get 3 times -3, which is -9, minus 1 is -10. So we're going to come down to -10, which is way down here, -10. So we're going to have a point, and this one's a solid dot because this is included. We have the equals to on this one, so -3 is included. Now for 2, if we plug that in, we're going to get 3 times 2. Well, that's 6 minus 1 is 5. So we're going to get, at 2, we're going to get 5, which is right here. This is where 5 is at. And this would be the line. So we would just simply draw a line here. And this is the line 3x minus 1. 3x minus 1. And if you see, it has a positive slope, specifically a slope of 3. And it's been shifted by 1. Now for the last bit, this is all the stuff greater than 2. We're just going to have -4x. So again, we need to plug in our endpoint here to see what's going on. So if we plug in 2, we're going to get -4 times 2. That's going to be -8. So we're going to come down here, -8's right here. So at 2, we're at -8, and it's a hole, because it does not have the equals to sign. And then this is again a slope, right? We're going to rise -4 and then run +1. So in other words, we're going to go down 4 and over 1. So we're going to go down 1, 2, 3, 4 over 1. That would be where our point would lie. And we could extend our y-axis, right? This is in the direction of -y, +y. And then we have our x-axis, all that good stuff. So from here, our line would go like this. This is what our function would look like. And we would simply put in our function. What is it? -4x. -4x is the function at this point. So you can see this is an example. First, you can break this into as many pieces as you want. And then each piece is going to have the different function. And they might not line up. So if we get like -3, we know to pick this middle one, because it's the one that includes -3. If we have like 5, we know to pick the bottom one, because these are all the numbers. And when x is greater than 2, this is the equation that we should use, right? We get -20. It would be, you know, way down here. But that's it. That is how you graph this. They're not too scary once you understand just sort of how to look at the domain splitting and the functions, and just understanding that, you know, this is kind of what y is doing. You know, y is moving up and down and all over the place. And these are like the areas that y moves. Once you understand that, it really just is just graphing. And so that's not too scary, hopefully. If you have any questions about this, let me know. Subscribe if you're a Citrus College student. Definitely feel free to stop by online tutoring. We're there to help you out if you're still confused. And we'll catch you in the next problem.